Well, welcome to Chapter 1. In Chapter 1, we're going to talk about what anatomy and physiology are, so what the terms mean, how they're related. Then we're going to get into some basic characteristics associated with all of living things, and as well as all of the systems that make up the human body. So the first thing we'll talk about is what anatomy is and what physiology is. The term anatomy means the study of form or structure. And since we're studying human anatomy, we're going to be looking at the structure of the human body. And this is a figure that shows the digestive system. So you have all different parts of the digestive system. You have your salivary glands, you have the esophagus, the mouth, the liver, the stomach, pancreas, gallbladder, large and small intestines, all part of that digestive system. And so an anatomy major or an anatomist would be studying the structures that make up the digestive system, how they are put together, what cells make up the tissues, what muscles surround the organs, stuff like that. Physiology, that term means the study of how structures function. And since we're studying, again, human anatomy and physiology, we're looking at how the body structures function. And so a physiologist would actually see this in a much different light. They're going to see the same organ system, the same structures, but they're going to be looking at what is occurring, what processes occur in the mouth. How do the salivary glands release saliva? How is the esophagus moving food from the mouth to the stomach? That's how a physiologist sees things. So they study the same structures, but they study them in a different light. We study anatomy and physiology together. We don't study anatomy only or physiology only. We study anatomy and physiology as one. And the reason for this is structure and function go together. They are inseparable. A structure is going to determine a function. If the structure is improper, then the function will be improper. And this is how we can identify disease or damage, because if the structure is damaged, then the function is damaged, and we have to fix the structure so the function can come back. So one thing you'll get out of my class is that structure determines function. And you should say that 1,000,000 times every day. Not literally, because 1,000,000 times is a lot, but say it right now. Say structure determines function. Structure determines function. You can kind of get it into a sing-song, Structure determines functions. Structure determines function. Structure determines function. Get into your head so that you remember that, because every exam will have some type of question, and the answer will always be, for at least one question, structure determines function, in general, I should say. And so here we have a wagon full of wheels. Weird, but hey. And there's a human over here pulling the wagon, and there are two humans back here pushing the wagon. The wagon isn't turning properly. The reason is because look at those wheels. Those wheels are square. The structure of the wheels is not going to allow the wheels to move easily over land. So it doesn't have the function it's supposed to have. If we change the wheels, we turn them into circular wheels, what we would expect to see on a wagon. Now, moving that wagon will be a lot easier. It'll still be heavy, but at least now we can move it because the wheels will turn as you pull or push. In anatomy, we can study a lot of individual fields. So some people might specialize in microscopic anatomy. Microscopy in anatomy has two major divisions. You have either cytology, so that's the study of the cells that make up structures, or histology, the study of tissues that are made up from cells. And so here, these are simple squamous epithelial cells. When you do a cheek scrape and you're looking at those cells, this is what you're actually seeing. You're seeing simple squamous epithelium. This is stratified squamous epithelium here. And that's a tissue, and that's what makes up the skin of our body, the internal mouth tissue. We can also study large macroscopic structures. This is termed gross anatomy, and gross anatomy is also divided into different disciplines. So we can look at gross anatomy as either a systemic anatomy or as a regional anatomy. Systemic anatomy means we're studying the entire system. And this is how, in our class, we study anatomy and physiology. We look at the systemic anatomy and physiology. In upper division anatomy and physiology classes, a lot of times you'll study the regional anatomy and physiology. So with systemic anatomy and physiology, we look at the organ system as a whole. And in this case, this is the endocrine system. These are different endocrine organs, which would be studied by an anatomist. And then we'd study the function of the organs and the hormones produced in physiology. Okay. A regional anatomist is going to study one region, look at, so this is the tarsal region, and look at all the structures in the tarsal region. And then the physiologist, regional physiology, would study how the physiology of that region works. How do the blood vessels, how do the tendons, how do the bones all function together to make the tarsal region work. Macroscopic anatomy can also be studied as surface anatomy. So surface anatomy looks at a specific surface, and you can feel the structures, and then you can identify internal regions. So here is where the larynx is located, in the throat. And you can feel the larynx if you're touching your throat. You can feel a little bump, and that's where that larynx is. If you have any inflammatory inflammation in that area, it might be swelled up. This here is the epiglottis. If the epiglottis is swelled up, it can actually cause breathing issues. So that would be one reason you might study surface anatomy. And really quick, a lot of doctors use surface anatomy to infer about how a patient is doing. They might feel the lymph nodes in the neck, or they might feel under the arms, or feel the forehead to see if you feel hot. Those are, what that's called is palpating the body to infer information that is deeper. Okay, so you're looking at the surface anatomy to try and get information about internal structures. We can also use comparative anatomy. We can study gross anatomy as comparative anatomy, where we're comparing the structures of one or of multiple organisms. So this is often what we do when we're trying to determine how different diseases will affect the body, or how different treatments will affect the body. So you can't study new drugs on humans, that's considered illegal unless you've already went through all the testing on non-human animals like chimps or rats or whatever you're testing on. And so we use comparative anatomy to take in information, and then we can use that information to infer information about the human body. We'll do that in this class when we're dissecting our rats, actually on day 1 when we get together, and when we are dissecting the pigs, looking at all the structures. Because we don't have a human cadaver, so we use these other animals to get information. You can also study embryology. Embryology is the study of the development of an organ system or of the organism. So in this case, we're looking at the embryology of the nervous system. So what does the brain and spinal cord look like at 25 days gestation time? You can see the structures and how they are changing until we hit full term. We can study pathologic anatomy. Pathologic anatomy, wow, that's a hard word for me to say for some reason, looks at how disease changes the structure. So healthy legs versus diseased legs, and this actually is a disease known as necrotizing fasciitis or flesh-eating disease. We can look at radiographic anatomy, where we're taking x-rays or MRIs of a structure, and then we are seeing how they differ from the healthy structure. So here we have the healthy legs, and then when we have legs that are broken, you can actually see those broken bones in an x-ray, and then we can fix them. Physiology also has multiple disciplines. We can study physiology associated with specific organ systems like cardiovascular physiology or neurophysiology, but we can also study physiology associated with disease. So how does the organ system function normally versus how does that organ system function with disease? And that's called pathophysiology. So we talk about the structures of the human body and the functions of the human body, but what makes up those structures and functions? Well, all living things are organized. It's one of those characteristics that make living things living. And so from the most simple to the most complex, we start out with these atoms, which we'll talk about in chapter 2. Atoms come together making molecules. Molecules come together to make large macromolecules, and macromolecules, organic macromolecules, are what make living things, make up the majority of living things. Macromolecules also, what was I going to say? We'll talk about macromolecules, molecules, and atoms all in chapter 2. Macromolecules then come together and form these structures called organelles, which are tiny little structures inside of cells that do the cell's activities. And then when we get these organelles and we put them all together inside of a plasma membrane, we produce cells. Cells are the basic unit of life. And once we have a cell, we now have a living organism. Cells come together forming tissues. Tissues come together to form organs. Organs come together to form organ systems, and then the human has 11 organ systems, and that forms the organism itself. So I'm going to stop here for the first chapter because these videos can only be up to 15 minutes, and I'm already at 14 and a half minutes. So our next lecture will start on the properties, the properties common to all living things. Okay? Bye.